Thank you for joining us. My name is Jay Clifford, a developer advocate here at InfluxData. I'm joined by Evan Kaplan, our CEO. Evan, thank you for joining us.
Thanks for having me, Jay.
No worries. So I'm going to ask you the hard questions today. We're going to be talking about 3.0. So we've been on quite a journey with InfluxDB 1.x, 2.x, and now 3.x. So could you sort of elaborate to me why 3.0? Why do we place our bets on 3.0?
Yeah, it's a really good question. And they are bets. They're pretty important strategic interventions. We're a medium-sized business, so every significant architectural bet on a new platform, on an emerging platform is super important. So we had, one of the things that's been great about our leadership role is we really get to see how customers exercise the platform. And I know you know that because you're close to it, right? You know, how they break it, how they challenge it, what they want to do, where they want to go with it, what. And I'd like to say we've had this perfectly smooth ride where every customer loves us from day one and it works out perfectly, but that would be a fantasy. That's just not the way products and technologies develop. And so over our 1.0 and 2.0 release, we learned a bunch. And so probably, I'm going to say it's almost 3 years ago now, we started the work with a separate team to build on an open source data engine called IOX. And it's built in Rust, which, as you know, is a really powerful language for building scaled out server capabilities and databases. Takes a lot to program in Rust, but it's a pretty hardy language once you build something in it. And so there was one bet on that, is building this memory tolerant and really strong language. Second was, we saw a lot of our customers run into significant cardinality issues. If you think about the richness of data with these time series measurements, and the richer the data gets, the bigger the cardinality problem is. For folks who don't know what cardinality is, it's just the sheer number of tags and fields that you have to use in order to describe something. And obviously, the better you describe something, the more useful it's going to be for your foundational AI models and for your monitoring and observability dynamics. And so you wanted to get really good at cardinality. 3 is, we really wanted to reduce the storage costs. So the cost of running this infrastructure. And so we stored mostly in memory kinds of stuff. And so how could we do that with object storage, a much cheaper level of storage, so that you could have different levels and that sort of stuff. So we wanted to have that in our 3.0 version. And really, really importantly, but not as well understood, is we wanted to fit into this notion of a Lakehouse pattern, or the new Lakehouse emergent. So anybody who's been watching the industry over the last 4 or 5 years has been watching the emergence of these cloud-based data warehouses in the form of Snowflake and to some extent Databricks. Mm-hmm. And I think it was Databricks that coined the term Lakehouse, right? Because of a warehouse and a data lake and a combination. And the notion being is that you can, there's not even a word, but you can de-silo your data, pour it all into a giant lake, or now Lakehouse, and be able to access it, carve it up, use it, and that sort of stuff. And so in order to support the Lakehouse pattern, we had to do a couple of things. One is we had to support native SQL. Now, InfluxQL was SQL compatible, but it wasn't true native SQL. So we had to support native SQL. And that was important because now the query engines that use these lakehouses can also query Influx. But maybe as importantly, we had to start supporting some of these new standards around Apache Parquet, like Iceberg. And we don't support it yet, but will Delta Lake, right? The idea being is that we can be an extension. Our file format allows us to be an extension to the Lakehouse pattern. So they can query us as if we're part of that general data lake or Lakehouse that they're keeping. We think that is the modern data architecture that has these lakehouses at their basis, and that databases sit in front of those lakehouses to do the performant work in front of them. If you think about the Lakehouse pattern, it's a batch pattern, right? It's mostly batch analytics. It's not real time. There's no requirement. So if you really want to do sophisticated real time, fast data collection, fast data reads, queries, all that sort of stuff, you're going to have something in front of those lakehouses that's capable of doing that. We built Influx 3.0 to be that thing, because we think that's an important architecture coming, and we think time series is obviously foundational for that kind of stuff.
So when we think about this with 3.0, then we have high performance, we're reducing the overall storage cost, we're really trying to become that open plane of data that's interoperable with things like Snowflake. So one of the qualities that I think we've missed that I would love for you to get your opinion on, that'd be really cool, is open source. InfluxDB has been inherently open source since 1.x and 2.x. How do you see our contribution to open source going forward? Is it going to be in an InfluxDB 3.0 open source offering? Is it going to be contributing into sort of open source projects that make up InfluxDB? Can you tell me a little bit more about that?
Yeah, it's a great question. So if you look at our values as a company, open source is one of the 5 values that we articulate to all of our employees. It's why a lot of people join the company. We have developers all over the world who work on this. It's a really important dynamic, and it certainly was important for Paul when he started it. We now have roughly 1 million active instances that run daily, right? And I don't know, maybe 2,000 plus are commercial. The rest are open source. So we have to take that world, and we do take that world seriously. So with regards to 3.0, we'll have an MIT and Apache licensed version of 3.0 that will be out there. We'll also have a community version that won't be an MIT Apache license, but it'll be free, and people will be able to use it. And so we continue the basic commitment to offering the database to developers and hobbyists and other folks who want to work with it without friction. So that's one. But maybe as importantly this time around is when we looked at the architecture for 3.0, we had a clear view that we wanted those components not to be just built on our own intellectual property, but rather on the backs of other really successful and emergent open source. So we have this concept called the FDAP stack, which is now being adopted. I think it is the foundation for the modern data stack. And FDAP stands for Flight, Apache Flight, which is an SQL engine that can handle a variety of different SQL query engines and Data Fusion, which is a core data engine that is also a huge number of contributors, becoming increasingly popular and super performant. And by the way, we're a major committed to that, but a lot of other people are, and we benefit from their contributions as they benefit from ours. Apache Arrow, which was started a while ago with companies like Dremio and the like, and that data format for working. And then Apache Parquet, which is the foundation for all these Lakehouse patterns. We think FDAP is the foundation for the modern data stack. We think most companies are going to get serious, are going to look to build around those FDAP standards. There's just a tremendous benefit. Now, different vendors are going to commercialize it in different ways, and I think that's great. That's the best of the open source world. But I'm super excited about it. It does fit clearly into that Lakehouse pattern.
So, Evan, you've explained the FDAP stack. We've talked a little bit about the data lake as well. And what I really wanted to kind of understand is, where do they relate? What can we do with these two technologies that brings them together?
Yeah, it's a really good question. The gist of it's really quite simple, and I'm going to put this in broad terms. If I look at the Lakehouse pattern, that's that Snowflake and Databricks and other people are emblematic of them. The fact that it's in a Parquet file store creates a kind of foundational layer then to marry other stuff. And then if you walk up the stack from the file store to the in-memory store, which is the Arrow, and up through the Data Fusion, which is the engine, all that, what you come is what our thesis is, and we firmly believe, and we're not the only company, but a lot of contributors to each of these projects, right, is that becomes the modern data stack, right, with the Lakehouses sitting beside it, sitting behind it as foundational piece. So we view that relationship as being really important. This is the natural way to collect the data, insert it, use it, and Lakehouses are the natural places to store long-term cold data, if you will.
So building that open standard and providing that interoperability.
Yeah, I think it's an emergent standard, but I think it's, I think a lot of people are using it, I think
that's the cool thing though, right? It's like every technology is emerging. It's how companies like ourselves try and make this the standard and how people move forward and you know.
The key trick to really great software that has really great outcomes is reusable components.
Right.
And one of the beauties of open source is the ability to have these reusable components. And now we've got multiple vendors contributing to these things. And so they get better and better and better over time. And so we're happy to be part of it.
I love that. It feels like our open source commitments evolved. It's like we're still offering that open source product, but then we're also committing to all of these open source projects, which are enabling other companies to create their own businesses on top of that.
And don't forget Telegraf, which is probably the world's most successful, probably most successful open source project. So many, Amazon uses it, Microsoft uses it, Datadog uses it. I mean, a lot of people use Telegraf to collect it, and that's a huge part. So so this is our life, you know. Open source is foundational for us. Yeah,
I mean, this is one of the main reasons why I even joined InfluxData, was just that commitment to making developers' lives easier, better in every sort of form. So
good. I'll be looking for commits from you and additional code.
I better make sure I do that. Yeah. Fantastic. Well, thanks again, Evan, for your time. It's been brilliant talking to you over this. Thank you all for joining. We would love to know what you're going to build with InfluxDB, and we'll see you next time.